Assalamualaikum, my name is Muhammad Najwan bin Abdul Rahman. So for my part, I will present about how to make the single line diagram based on our questions. So first thing first, this is the complete single line diagram with the harmonic load. So I will make a new one to show you how to make the single line diagram without the harmonic item. So first thing first is we look on the right. There is a power grid, so we click to it. Then we drag into inside. So we double click it. Then we put the rating here is 11 kV. So we click the next short circuit. We insert the AC rating for the 3-phase is 250, and the XR for 3-phase is 10, and the single phase is 12. So we click OK. Then for the auto bit in ETAP, we click this button. To use this button, we need to click back at the power supply. Then as you can see here, there is a thing that we can choose, and also there's no things that we cannot choose. So next we insert the bus, which is bus 1. Click it, double click it to check for the bus 1, which is the kV is 11. Then we click OK. Next we put a cable. For the cable sizing, we click the library and then we choose 50 Hz. I choose 15 kV. For this we choose 3C, and then the type of cable is copper. For the diameter, I assume 185 millimeters. The number of conductor, I put 1, and the length is 50 meter. Then after that, click OK. Next we put the high voltage circuit breaker because it's from supply. You can change the symbol by right click. After that, we put the transformer, 2 winding. Double click into transformer. The rating for the primary is 11, which is from the supply, and for the secondary to divide to the load is 0.4 kV, and for the power rating is 2 MVA. So for the impedance, I just click this typical Z and X over R because it's from the library, but the question said it's 6, but you can just click by this button from the library. Then we click, then we check it for the sizing. Loading transformer, I put 2. So this 2 is very important because we can insert the value. So then we click OK. Next we add some cable for transformer to substation. For the cable, same method. Choose 50 Hz, 15 kV. For this we choose 1, and the type of cable is copper. For the diameter sizing, I put around 630, and the length is from the question it's 30 meter. For the number conductor of phase, I put 4. Then we click OK. Next, put the low voltage circuit breaker because of the transformer secondary to the load. We need to lower the voltage to supply the load to every load. Next, after done that, we insert the bus 2. So we can zoom here, make it more longer because we have 5 load. For the load number 1, we need to insert the low voltage circuit breaker. Then the cable sizing for the load, same method on library, just the same. We use 3C copper wire, and the sizing is 300 millimeter. For the number of phase, I put 2, and the length is 60 meter. Then we click OK. Next, we put the motor is by using induction motor. So we move to click the nameplate. Before this is horsepower, so we change it to kilowatt. For the motor number 1 is 400 kilowatt, and the power factor is 85%. So as you can see, if we insert the kilowatt and also the power factor, it will appear the efficiency and also the other values. Then we click OK. After that, so for the motor number 1 already done. So we move to the motor number 2, same method. So for the cable number 1, library, copper wire. For the sizing, I assume as 300, and also the length I put 100 meter, and number of conductor also 2. Then we click OK. For the motor number 2 is 250 kilowatt, and the power factor is 90%. After that done, we click OK. Next, for the load number 3 is lighting load, but this time we not use the low voltage circuit breaker. We use the fuse because of for the lighting. So as you can see here, you need to find the fuse. Double click on it and change to the 15 kilowatt, and then we put cable. For the cable sizing, same method, as motor. C copper wire. For the sizing, I choose 150 millimeters, and for the length is 60 meter. Next, we use lighting load by using lamp load. Double click on lamp load, and as you can see here, we need to insert the rating. So for the rating is 150 kVA, and the power factor is unity. I put it around 100. So then we click OK. Next is HAZIQ. I use induction motor for HAZIQ. We use low voltage and cable, and also induction motor. So just name it HAZIQ. So for the nameplate, we change the horsepower into kilowatt, around 300 kilowatt, and the power factor is 80%. Then we click OK. For the cable, same. And the sizing is around 240, and the number of conductor is 2, and assume the length I put 90 meter. Next is the future load. And for the diameter sizing, I put 240, number of conductor 1, and length I assume as 80 meter. So for the future load, in this single line, I use the lamp load. So just name it future load. And the rating I put around 200, and the power factor is, I assume as 100. Then we click OK. So this is how to make the single line diagram. Next, I will teach you how to make the relay. So first thing first, click back this auto build. The first one, you need to insert the CT ratio. Before insert the CT ratio, look at your right. We can see the current transformer, so we put it after the supply. So we can see the rating is 150. Then we click OK. So next we insert the overcurrent relay beside it. Then we put another CT ratio after the cable For the rating is 150. And for this rating is around 3000 ampere. So we connect it to the overcurrent relay. In this transformer, we also need to add some differential relay beside the overcurrent relay. Okay, done. So next we move to the 5 load for every overcurrent relay in each load. Same method like upside. Put overcurrent relay, and the rating is 800 for motor 1. Then click OK. Put the overcurrent relay, then connect it to the CT ratio, same as motor 1. For the CT ratio of motor 2, 500. Let's put for lamp load, lighting load, same overcurrent. It's around 300 for the rating of load lighting. For the ratio for the HAZIQ is 600. Then we put this same for the last future load. Then we connect it to the overcurrent relay. For the ratio is around 400. Okay, so that's all for my single line diagram. How to make it for the every starting before we continue to other method, which is load flow, short circuit, motor starting, harmonic, and also protection. So that's all for the starting single line diagram.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad AFANDI, number matrix DE230060. Okay, so I will present about our load flow analysis. So first thing first, I will switch on the load flow and run the load flow. Okay, so we have to find the voltage profile at all buses, and power factor at the main bus, transformer loading percentage, and feeder current and losses. So for the find the voltage profile at all buses, so we enter the load flow report manager and search the result for the load flow report. So here we have for all our buses in kilovolt. So bus 1 have 11 kilovolt, bus 2 have 0.4 kilovolt, bus 8 0.4 kilovolt, bus 15 0.4 kilovolt, bus 16 0.4 kilovolt, bus 17 11 kilovolt, bus 19 0.4 kilovolt, bus 22 0.4 kilovolt, bus 23 0.4 kilovolt. Okay, for the next is we have to find our power factor at the main bus. So our main bus is bus 2. So the power factor here is 98.2%. For the transformer loading percentage, so we have to click the load flow analyzer. First, we have to click the report type, branch result, and here we have the transformers 1, the loading percentage for our transformers is 64.5%. For the feeder current we have our cable 1 is here we have 1877,641.3, 399.5, 22.4, 5.3.7, 297.2, 69.81. Next, for the losses, click for the load flow report manager, summary, and losses. So here we have the cable losses that connected to our load. Thank you for watching.
Assalamualaikum warahmatullahi wabarakatuh. My name is SAFWAN bin AIZIZI AZUAR, matrix number DE230099. I will be presenting about the short circuit analysis. This is the button to enable short circuit simulation. And then to run the 3-phase short circuit calculation, this is the 3-phase at 11 kV bus. Our total load current is 11.394 kiloamps, and at lower voltage bus it is 46.542 kiloamps, and at each feeder lines it is 2.695 kiloamps, 2.0 kiloamps, 0.7 kiloamps, 2.7 kiloamps, and 1 kiloamps. And then we can proceed to line to ground load short circuit analysis. At our 11 kV bus it is 16.87 kiloamps. At low voltage bus is 41.257 kiloamps, and we obtain 0 kiloamps at each of our feeder. So the recommended ratings at 11 kilovolt amps is to calculate the required recommended ratings, we should multiply it by 1.25 to enable 25% headroom. So this would be around 20 to 25 kiloamps. And the recommended for low voltage bus, since it is 41 kiloamps after we calculated it with 25% headroom, and with according on the market circuit breaker, we can find that 60 kiloamps is the most suitable for our low bus voltage. That is all from me. Thank you.
Assalamualaikum. Okay, my name is UMAYR bin FADRI, and I will present about harmonic analysis. So this is our single line diagram. Okay, so first of all, this is our bus 2, which is the main bus. Okay, to execute the harmonic analysis, first we press the harmonic icon on the left side, and we press the study case, and we need to make sure the plotted buses is a bus 2 because it's the main bus. Also the cable that plotted is cable 2 and 3, which is connected to the motor. Okay, after we make sure it's connected properly, we press OK, and we run the harmonic analysis workflow, which is here, run harmonic load flow. Okay, so as we can see here, the total harmonic distortion
is the 9.3%. Is for the main bus. To obtain the harmonic distortion at the motor, we need to press the harmonic analysis plot, which will open the plot manager. Okay, so we tick the cable 2 and 3, also the waveform and spectrum. We will obtain the spectrum and the waveform for motor. So as we can see here, the fundamental is higher, is the highest compared to the others wave harmonic. So which is shown that our system is working as expected. So we close this. To be make sure that we need to connect the low voltage circuit breaker and the harmonic filter to the main bus to potential as a potential mitigate method. So that's all for harmonic analysis. Thank you.
Assalamualaikum. My name is Muhammad HAIKAL bin Muhammad AZARUDIN. Today I would like to simulate about the motor starting analysis. So for the first, we need to do a motor acceleration setting for our motor starting analysis. For the first one, we need to change the motor model, inertia and load, which is we assume the value for each parameter and based from the question. Same goes to the motor 2 for change the each setting for model, inertia and load. So after that, we need to run dynamic motor starting. Okay, here we have the motor starting time slider, which is we need to adjust the time until we get the current stable. So for example, which is when 3.34 second, the line is still red, which is the current is not stable enough. After that, we need to adjust until we get pink color. So as you can see here, when time hits 9.64 second, we get the current stable, which is it goes to the pink color. And after that, we can see the motor starting plot. So here we want to see the motor parameter, which is we can select motor 1, motor 2 and motor HVAC. After that, we can select the graph framework, which is slip, speed, current line, voltage bus, acceleration torque and motor torque. So as you can see here, the slip for both motor 1 and 2 is good, which is good enough for a motor to down when it hits 9.64 second. And then after that, we have the speed, which is it goes up normally. And then we have the current line, which is where current will drop when it hits 9.64 second. Then we have the VT bus, which is when it hits 9.64 second, it really goes up a little bit for inrush current. Then we have the acceleration torque, which is we have motor acceleration torque for motor when it goes up maximum when it hits 9.64 second. Same goes to the motor torque, it will goes up when it hits 9.64 second.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syakir FAIZA, DE number DE200052, and finally I will present the protective device coordination for our project in ETAP. So first of all, we need to ensure that all the relay that have been put in the circuit alongside with the circuit breaker have their own rating. So in order for us to do that, we can go, for example, in here I have the overcurrent relay editor. We go to OCR and we can pick each manufacturer that we like, and we need to also pick the model. Same goes for the circuit breaker. So here we can go to the rating, go to the library, and we pick the right circuit breaker based on our parameters. So in order for us to run the protective device coordination, first we need to click on the star protection and coordination icon here. Then we edit the study case, and we need to choose which bus we need to fault. So in this case we choose bus 1 and bus 2. After that, we can put the fault insertion on bus 2 because we have all the loads here. And here we have the sequence showing which circuit breaker trips. After that, we take all the component in the one line diagram, and we can create star view. So here is the TCC for the one line diagram of our project. So here there is a curve showing the time it takes for the circuit breaker or the relay to trips. So here is the relay, the curve for each of the relay, and here the thicker one here is the curve for circuit breaker. Other than that, we can also generate our own report to see the sequence of operation here. So we go to a report manager, click on summary and sequence operation, and here we go, the sequence of operation. This is the sequence for each of the relay to trips. So that's all from me. Thank you.